Good afternoon, students. Today we are going to do the topic the ionization potential or ionization energy or ionization enthalpy. These all are three names of only one topic, and you can call it by any name. But I will tell you one thing when to call the ionization potential or ionization or when to call ionization energy or ionization enthalpy. Okay. Now, first we have to understand the definition of this. We see what it is telling that the energy required to remove an electron from a neutral isolated gaseous atom and convert it into a positively charged gaseous ion is called ionization potential or ionization energy or first ionization energy. And this example is also given here. I will tell you here the important points of this. Okay, by red color. Okay, now see the energy required from a neutral isolated gaseous atom and convert into positively charged gaseous ion. Okay, these three are the keywords of this definition. Okay, these three are the keywords of this definition. What they are now let's understand this definition. Now what is their energy is required? Okay, energy required to remove an electron from a neutral isolated gas metal means it is a gas. Okay, it is not having a charge, it is a neutral and it is a gas. Okay, and the if we give it ionization energy, okay, if we give it an energy, then we will get gaseous ion. Okay, positively charged means a cation we will get, and we will get a electron. Okay, the energy required to remove an electron. Okay, energy required to remove an electron from neutral isolated gaseous atom to convert it to cation is called, okay, is called ionization energy. And we have to make sure that M can be any element. It is not sure that M can be metal only. Okay, now next is this is very important unit. He will not ask to write the unit in exam, but you have to understand this. See, ionization energy is measured in electron volts per atom and SI unit is kilojoule per mole. Yes, then you will tell that there are two units. Okay, no, this is we can say this is SI unit and this EV per atom. This is another unit, but this EV per atom, electron volt per atom, we can use if we are speaking ionization potential, then we can use the unit EV per atom. Or and if we are speaking the if we are speaking ionization energy or ionization enthalpy, then okay, then we have to use the 7, that is kg mole minus 1 or means kg per mole. Okay, now next is same. Next is ionization energy. This is a depends on, okay, uh, all all the we can say atomic properties mainly depends on this atomic size and nuclear charge. This both atomic size and nuclear charge. Okay, but okay, now what is telling that if the atomic size will be increased. Okay, atomic size greater the atomic size, less the ionization energy, and more the nuclear charge, less is means the less is the means less we can say less ionization and energy will be needed. Now next is trends. This trend is very important of this trends in ionization energy. Then electron affinity trend is also important. This the three properties which I will going to teach now. The ionization energy, electron affinity, and the electron negativity are very important. I will teach you in a whiteboard also, so you can understand it properly. Okay, now across a period, Now the ionization energy tends to increase as one moves from left to right. How? Okay. How I will tell you in a whiteboard. See, just I will take the period table photo so you can understand it completely. Okay, just wait. I will take your 2 minutes, not more. See here. Now, let's get back to ionization energy trend. Okay, here. Now see what I am telling you that when what the trend said that uh, move when we move across the period, okay, the ionization energy will increase. Okay, why it is? See, if we uh, take like this, then ionization energy will increase. You know why? Because see, LINBE. Okay, LIBE, then BCNOFNE means that these are the elements of second period. Okay, now what will happen here? That if we move across the period, then ionization energy will decrease. You know why? Because see, as we move from the left to right, we are able to see that nuclear charge also increases. Okay, as the nuclear charge increases, the as the nucleus increases, the ionization means the bond between the size will increase. So the charge between the nucleus and the last electron will also increase. So because of increase in nuclear charge and decrease in atomic size, the while moving from across means while moving across a period, it will increase. Okay, it will increase. Now if we check, okay, now let us check down a group down a group. If we check from down a group, then we are able to know that it will decrease. You know why? Because as the size will increase from first period to seventh period, okay, as the size will increase, okay, so the distance, no, but not the distance, but uh, we can say the nuclear charge will also increase, but it will not have a effect on the last electron. Okay, it will not have a effect on last electron, means last outermost shell electron. Okay, it will not have a effect. So we can remove it easily. So the ionization energy will decrease as the size will increase and the nuclear charge doesn't have the effect in on the last outermost shell. Okay, so it will decrease down a group. Now, and now you have to check this here. There is a exception here that second group and 15th. Okay, here they are given first, second group. Okay, second group and 15th. Okay, 15th group have exceptions. As I told you that as we are moving from the left to right, the energy will increase. Okay, but you can see here the Be will have means boron should have more ionization energy than beryllium, but it is not. It is vice versa. That beryllium is having more ionization energy than boron. Okay, and same like here that oxygen should have more ionization energy than nitrogen, but it is vice versa that nitrogen is having more energy than oxygen, more ionization energy than oxygen. Okay, next as I have taught you this down a group. Okay, and now I have taught you this down a group, so you have to just understand these trends. Okay, And this note is very important here. That note, helium will have ionization highest ionization energy. You don't have to remember the value, but you have to remember that helium will have the highest ionization energy, and metals have low ionization energy. And non-metals will have high ionization energy. It is because, as I told you, as we move from down top to bottom, the ionization energy will increase, and as we move from across the period, the ionization energy will increase. Okay, this is the trends you have to understand, and I will tell you how helium is the have the highest ionization energy. See, now what I have told you, that as we move from across the period, it will have high. Okay, it will have highest. Means it will increase, the ionization energy will increase, and as we move down it will decrease. So if we take the first period, so when we will it will decrease, and this if we go here means when we check about the period it will increase, and when we check about the groups it will decrease. So when we check out the periods, when we check about the period, see the first period is short period, so we don't have to check the down as it is decreasing. We have to check how much it is having, how much highest it is having. So it is He. Okay, it is He means helium. Okay, means helium. So helium is having the largest ionization energy. Okay, helium is having the largest ionization energy. Now next. Next is electron affinity. Okay, now I will first underline the important points here. That the amount of energy released while converting a neutral gaseous isolated atom into negatively charged gaseous ion by addition of electron. These are the keywords you should have in your definition when you are writing in exam. Okay. Now, what is the difference between electron affinity and electron means not ionization energy. Okay, the difference is that, see, here is energy, there was energy required, here is energy released. Okay, here we have to convert from an here there we have to convert a negative uh, convert to a cation. Here we have to convert to anion. Here they had we have to, in ionization energy we have to mean we means we can say we have to in ionization energy to add, we have to take one electron. Okay, so we are adding the ionization energy. Okay, now here now we are here adding. Okay, so we are get, now we have to form an anion, and it will give us a electron means a electron affinity. Okay, now here I will explain with example that, see, X is an element, and we have to take it in gaseous state. Okay, now if we add one electron, then it will form an anion, it will release electron affinity. Okay, or electron gain enthalpy it will release. Now here are the same factors that electron affinity depends on the atomic size and then nuclear charge, and there is a same reason for it, that atomic size is the smaller the atomic size, the greater is the electron affinity, and nuclear charge, the how much it will be more, the more is the electron affinity. So it is not need to explain it again. Okay, now next we have to check the trend. Now if we check in a period, then we notice that from left to right in a horizontal row of periodic table, it will it will majorly increase. Okay, it will increase, and see here a table is also given. You can check downside here, that electron negativity value. See, as we move from left to right, it is increasing. See, 1 1.5, sorry, my mistake. it is electronegativity values. uh we will study this electronegativity in the next lecture, next not next lecture, the next topic. It is electronegativity. Okay, by mistake I have took understood that it is a electro affinity table. Sorry, by mistake. Now if we check here, see, this is a table of electronic affinity. Okay, if we check here that Li, Be, then they are increasing, but there is also exception, as I told you that in a second and 15th. Okay, in the second and the 15th it has a exception here. Okay, same it has a in ionization energy, and same it has exception in, and this here uh, electron electronic enthalpy. Okay, now if we move down a group, then down a group, if you move them going from top to bottom in a group, it will decrease. Okay, it will decrease. Why? Because see here it will decrease because it has see, when it will see, when we talk about the nuclear charge. Okay, when we talk about the nuclear charge, more the nuclear charge, more the see, we have to talk. I told you now only that more the nuclear charge is there, greater is the electron affinity. Now I will explain you the periodic table. See, now see here that if we take out the second group, there is exception in the second period and the 15th, sorry, third second group and 15th period. So 15th group means here there is exception. Okay, here is exception and here is exception. Now how it will increase and decrease? Okay, how it will increase and decrease? Now how is the trend? As we move from top to bottom, as the nuclear charge will increase, okay, the atomic size will increase and nuclear charge will also increase, so the electronic affinity will decrease. Now we are telling that here you will telling that here you will telling that greater the nuclear charge, greater is the electronic affinity, but you have to understand that here as the nuclear charge is increasing, but as the atomic size is also increasing with it, so it is not having an effect on the last outermost shell. Okay, and if we check in this second, we check, so the nuclear charge increasing and atomic size is decreasing, so it has, okay, so it will have it the electron affinity will increase across the period. Okay, okay, so we will move to next topic, electronegativity. Now I will underline for I will underline first the main points. Okay, I will underline first the main points here in this definition, that first electronegativity is a dimensionless property. Then this whole definition you have to just this definition you have to uh, remember by logic. Okay, now what is electronegativity? Electronegativity is tendency, okay, of an atom in a molecule to attract the shared pair of electron towards itself. Okay, it is called electronegativity, and as it is a tendency, so it is a dimensionless property, and it was discovered by Linus Pauling. Okay, now if you check that how which it depends, it will depend on atomic size and nuclear charge. The greater the size of atom, the lesser is the electronegativity, and the greater the nuclear charge, greater the electronegativity. Same the yeah, there. Okay, same the, can say the factors are there. Now if we check the trends in electronegativity across the period, it will, okay, it will increase. You know why? Because electronegativity increase from left to right in a period. Why? Because as the nuclear charge is greater, and so the electronegativity is greater, and the atomic size is less, means very small, it will decrease, so the electronegativity will increase. Okay, and down a group, if we check, then electronegativity decreases down a group, because as the electron nuclear charge doesn't have an effect, okay, on the last, last outermost shell, as the electronegativity nuclear charge doesn't have any effect on the last outermost shell, okay, last outermost shell. So, and the atomic size will also increase. So we can say here that the down a group, if we go, it electronegativity will decrease. Okay, now we will move on the next topic. Not next topic. Uh, there are there are here. Okay, now here note here note is there that generally metals show lower electronegativity as compared to non-metals. As I told you, the down group there, as we can see in periodic table, that here if we go down group, there is a metal. Okay, here it is a metals, and here it is a non-metals. Okay, here it is a metals, and here it is a non-metals. Okay, now as we check here, that as it is a metals and non-metals here, that now see, as we go down a group here, the it will decrease, and as we go uh, across a period here, it will increase. By this we can say that non-metals have a great electronegativity, and metals have a low electron negativity. Okay. Hmm. Now there is a important point here also, that elements of second period differs in properties to from the respective groups. And this is due to small size, as I told you, that as we move from down a group, the atomic size will decrease. Now if we check here the diagonal relationship, it is between the diagonal relationship between the second period and the third period elements. It is between Li and Mg. Be and Al means Li means lithium, Mg is magnesium, Be means beryllium, Al means aluminium, boron and silicon. As I show you in the here, that see, it is between, okay, it is between Li and Mg means lithium and magnesium, Be and Al, then boron here, Be and Al, and so on. You can check here also that it is between Be and Al, boron and silicon, and etc. etc. Now, if we check here, there is a note given which is a very important for you, that greater the value of electron affinity, easier is to gain electrons. Okay, if we will discuss in the second chapter, the we discuss in the second chapter the value of electronegativity in the ionic bonding. Okay, should be less than 1.8. Okay, sorry, it should not be less. Okay, it should be greater than 1.8. Okay, so here we can check here that here you will learn this in second chapter. Okay, you will learn here in second chapter. This note you will be able to understand in second chapter. This in-text question you have to do by you can do by your own, or you can check the solutions on my channel. Okay, now this atomic numbers and the mass numbers of, they are very easy. You can do by your own. Okay, because it is a seventh or eighth topic, eighth standard topic, and I will just I will explain you this. You have to just remember here one. Okay, one trick is there, how to remember the atomic masses. Okay, that you are able to check here that el- elements who have odd number of protons means the atomic number is odd, so they have to do the the A means the atomic mass is equals to 2Z plus 1. Means if we check here, there are two exceptions, the hydrogen and nitrogen. The hydrogen and nitrogen, except all the elements in the periodic table will follow this rule. And if we check about the even numbers, then we have to do, if we check about the even numbers, then we have to do double of it. Okay, and so means atomic mass equals to double of the uh, atomic number. Okay, so double. And the exceptions here, the even number of protons are the Be and Ar. Okay, Be means beryllium, Ar means argon. Okay, these are the exceptions here. I hope you are able to understand this topic. Okay, and if you are not able to understand, you can watch this video again. And because this is very important topic, I hope you are able to understand this topic. And you have to share this channel and subscribe this channel and like our all the videos. And you have to send the screenshot in our comment section below. And uh, we will check your views in our channel. And we are doing a giveaway to a person of iPhone 12, 12 and 14 Pro Max to only a one person. So just subscribe this channel and share to all your friends, as it is educational content to 10th standard, to share your friends. And you have a chance to win the iPhone 12 and iPhone 14 Pro Max only to a one person only. So goodbye, we will meet you